Good evening all, I'm Damayanti and today I'll be the host for this event. A warm welcome to the introductory session of IEEE Xtreme 17.0, and we are thrilled here to have you all here today as we embark on a journey of coding, collaboration and innovation. IEEE Xtreme is a 24-hour global algorithmic coding competition organized by the IEEE in collaboration with IEEE Computer Society. So now let's have a look at a video clip from an IEEE Xtreme chapter from a previous chapter that gives a visual glimpse of what IEEE Xtreme is. So today we are here to explore what is IEEE Xtreme, why should we participate, and how can we participate? So in order to conduct the sessions, let's welcome our guest speakers, Mr. Rahal Nanayakkara and Mr. Praditha Alwis, two esteemed graduates from the Faculty of Engineering, University of Peradeniya. They are Team Intergreat, participated in the IEEE Xtreme 14.0 and became the national runners-up, securing 68th position in world ranking. So without further ado, let's give our full attention to Mr. Rahal Nanayakkara and Mr. Praditha Alwis. We are eagerly looking forward to the wisdom you will share with us today.
Thank you, Damayanti. So I'll just get started with the presentation straight away. Yeah, I hope my screen is visible. So first off, I just wanted to give a brief introduction to IEEE Xtreme, the competition, in case there are people here who have never participated before. So basically, IEEE Xtreme is a global programming competition, algorithmic programming competition that takes place over 24 hours. So it takes place simultaneously at the same time across the world. So last time, I think around 15,000 students participated in this from approximately 65 countries across the world. So this is, I think, one of the largest and most recognized competitive programming events in the world. So the competition usually starts at 00 universal time. So that is around 5:30 a.m. in Sri Lankan time. And it goes on for exactly 24 hours. So it ends at 5:30 a.m. on the following day. This competition is hosted on a website called CS Academy. I think most of you here might be familiar with the platform called HackerRank. It's used in our undergraduate course for in various computing courses. So CS Academy is quite similar to HackerRank. And in fact, IEEE Xtreme used to be hosted on HackerRank, but now it is hosted on CS Academy. So quite similar to HackerRank, it has an integrated development environment where you can type the code there and test it against your own test cases, look at the inputs, outputs, and also submit the code in the same interface, and then it evaluates against all the hidden test cases and gives you a score. So it's very similar to how HackerRank works. So basically, the objective of the competition is to try and gain as much points as possible. So the teams, each team can have up to 3 members. So the teams will get together attempt to solve problems and maximize the amount of points they take. And of course, all teams will be given the same questions. So questions are usually released throughout the period of the competition. Like in most programming competitions, at the very beginning, there are 3 to 4 questions, and then every hour, the organizing committee will release either 1 or 2 new questions, depending on the progress that the participants are making. So talking a little bit about the type of questions that you get to see. This is a screenshot I took from CS Academy Practice competition. So basically, each question will have a name, and then it will be given a difficulty level, either easy, medium, hard. Then there is also, I think, hardest and advanced also. So this difficulty level is assigned by the problem setter, that is the person who designed the question. So sometimes it can be a bit misleading. Sometimes easy questions are harder than some medium questions. So it all depends on the person who sets the problem, and also on your own level of skill. So in addition to the difficulty setting, which you can see here, next to it on the right, you can also see a percentage. So that is the success rate of the question. So that will also sort of give you an idea on how difficult the question is. So basically what that tells you is how many or what percentage of teams have successfully scored full marks in that question. So in this case, you can see that more teams have completed the hard question than the medium question. So maybe it might be worth trying the hard question first. So it's always good to pay attention to both the difficulty level as well as the success rate. So the scoring for these questions, unlike Hacker Rank, so if you're familiar with Hacker Rank, you will know that the points allocated will depend on the difficulty of the question. In the case of IEEE-Xtreme, it does not depend on the difficulty level. So all easy, medium, and hard problems will have the same amount of points to start with. However, the amount of points will change depending on how many people successfully answer the question. So it actually depends on the total successful submissions by all the competitors. So if more people correctly answer a question, the amount of marks that are allocated to that question will decrease, because then it is considered an easy question. So basically, as soon as a problem is uploaded, when no one has answered it, this average points will be 0. So the total score for that problem will be 100. But as people gradually answer, and eventually if all the people answer, that is, if this becomes 100%, then this becomes 1, and the total score allocated to that problem will drop all the way down to 30. So depending on how many people answer, the score will vary between 100 and 30. So what this means is the score for question is dynamic. It will change throughout the competition. And as a result, your team score will also change throughout the competition, even if you do not make any new submissions. So suppose you answer a question as soon as it's uploaded and you score 100 marks, but then later, as more and more people answer that question, the total score of your team will also decrease, because the value of that question has also gone down. So one important thing to note when answering questions is, as I mentioned earlier, always it's worth attempting even the medium and hard ones, because there is no penalty for number of submissions. So you can try again and again and submit various solutions, making tweaks as you go along. And also you have the advantage of getting partial marks. So if your solution works for only some test cases, you will get half, or whatever marks, depending on how many test cases you pass. So that you can see in the screenshot, this 0-sum array question, I have got 64.29 points out of 100. And for the bottom question, the tick means I have got 100 out of 100 for that question. So the final score will be this 64 times the weight assigned to that problem. And in this case, it will be 100 times the weight assigned to that problem. So basically, the partial mark score is calculated based on how many test cases you pass. So some test cases will have more points attached to them because they are difficult test cases. Easier test cases will have lower points. So these questions are designed in such a way that there are various levels of answers. So if you write like a brute force, very simple solution, it will work for some test cases and it will probably time out or give an error for the larger test cases. But if you write a more optimized solution, you will get more and more test cases correct, and eventually you can get them all correct. So that depending on the level of complexity of your answer, the amount of points you score will also change like that. And as for answering questions, a lot of people have asked me what programming language you use. So the CS Academy platform supports over 25 programming languages, including all major ones such as Python, Java, C, C++, C#, even Octave, JavaScript, things like that. But I think for algorithmic programming and for competitions of this nature, personally, I think languages like Python and either Java or C++ is quite useful. So it's always good to know at least two languages. Some things are easier in a very high level language like Python, and some other things are easier in languages like C or C++ or even Java. So depending on the problem that you're addressing, it might be advantageous to know several programming languages, at least two, I think. So coming to like the forming a team in the competition, I'm not going to go into a lot of detail on this because I think our IEEE branch will fill you in a bit more on this aspect of the competition. So basically, a team can have between 1 to 3 members. That means you can compete alone or with 2 other people. So obviously, you have more chance of scoring if 3 people get together. And all members must have IEEE membership. So that is, they must be IEEE student members. And also they have to be sort of sponsored by a proctor for the competition. So that aspect is handled by our IEEE student branch. They will give you a proctor and set you up with everything you need for the competition. So I think Praditha, will you talk about this section? Hold on.
Sure. Let me share the screen. I hope you guys can see my screen.
Yeah.
Yeah. Okay. Let's talk about the types of problems that you will come across in IEEE-Xtreme. So most popular algorithms are greedy algorithms and string manipulation in IEEE-Xtreme. So you have to know about searching and sorting algorithms and mathematical problems such as convex hull, that means geometrical problems. And also one of the main algorithm is graph theory. So you have to know about Dijkstra's shortest path algorithm and breadth first search and depth first search. And in some IEEE-Xtremes, let's talk about game theory. So in some IEEE-Xtremes, we didn't have any game theory related problems. But in IEEE 14.0, there was a problem from game theory. So it's better if you can learn about NIM game. It's called NIM, NIM game. And you can almost solve almost all the problems in game theory using that algorithm, if you know the NIM game algorithms. And one of the main thing is one of dynamic programming. So I miss that. It's also important because when simulating something, or if you want to, if you are coming across some timeout errors, or if you are simulating anything, dynamic programming will be better. And also you have to learn about some data structures like double-ended queue, list, a linked list, etc. And let me change the slide, I think. Okay. So how to prepare. And again, usually problems are described as a story. Almost all the problems are described as a story. So you must extract the details from the problem definition. And you have to come up with the come up with a solution or an algorithm for that. So finally, you can choose any language you want. I usually prefer Python, but nowadays I use C++ because due to various reasons. So if you are like to learn competitive programming and you are new to competitive programming, start with C++ because C++ has a lot of data structures that will ease your coding. And if you are familiar with Python, that's also good. That's also a good programming language. So it depends on your choice. For an example, in IEEE 14.0, I used Python and Rahal used Java, and also the other member used C++. So we did the problems, we solved the problems using 3 different languages. So language doesn't matter here. What matters is the solution that you come across. So let me share an example problem. So I hope you can see this. So this is an example problem from IEEE Xtreme 14.0. So you can see that the first part of the problem is a small story. So the middle part is the problem statement, like what you have to do. There are a few conditions, so you have to meet with these conditions and try to develop an algorithm. So I won't solve this problem now because we have limited time. And also, most important thing is read the constraint. So you can see that here, this, I hope you guys are familiar with big O notation. So first read the constraints and try to develop an algorithm which won't give you a timeout error within that constraints. So here, the maximum you can, if you loop across this value from 0 to C, the loop will only have 500 iterations. So you can somewhat try a brute force algorithm here. But if you read the problems, you will see that you can try this problem. And this is a hard problem. First, you have to pre-compute the given conditions. Like you have to do a breadth first search and compute some values, then use those values to solve this problem. This is a special problem. So usually only 2 or 3 problems will be there from these simulations, or there will be about 3 problems where you have to pre-compute the solution. So here, this is a problem where you have to pre-compute some values. So you can see that first you have to read the problem, and this is the whole problem, and come up with an efficient solution. You can just refer to these constraints. So this says that it is guaranteed that there exists a way to reach the exit within 10 to the power 5 actions. That means there should be a ON algorithm. That means within 10 to the power 5 iterations, there's a solution that you will be able to come up with a solution. So I'll move on to the slideshow again. So here, the most important thing is first, it's better if the whole team or all 3 of you can read the problem and come up with the algorithm. So sometimes one team member might be proficient in graph theory, and another member might be very well good at mathematics. So you guys can collectively think the same problem and come up with an efficient solution. So the third bullet point is the most important thing when tackling problems, and how to prepare for it. So in IEEE Xtreme, thinking has about 20% weight. So you need to think, you should be able to think to solve about 20% of the problems. There are hard ones and there are some tricky, easy ones. The algorithm is a very simple one, like breadth first search, or it's just a binary number manipulation. So, but you have to think and come up with the efficient solution. And of course, you need to know about theory, like you need to learn about convex hull, sweep algorithms, and Dijkstra's algorithm, breadth first search, depth first search, and some string algorithms like Z algorithm and Robin-Karp, etc. But the most important thing is the practice. So if you are very familiar with, even if you are very familiar with theory, in IEEE they don't ask directly from theory. They just give a story, and in that story, when you are building an efficient solution, that part of the solution needs a specific algorithm, like destroy algorithm. You need to find the shortest paths and then use do some manipulations to get the optimal answer, or the final answer. So first you should practice well. So how to practice? If you are new to competitive programming, you can start, the best place to start practicing is HackerRank. So I'll share, I will share, share. Yeah. So in HackerRank, I hope you guys can see my screen. In HackerRank, there's a category called problem solving. Under that, you can solve many problems. For an example, if you want to solve basic problems under problem solving, you can tick that and choose any problem from here. So usually basic problem solving, under problem solving basic category, there are only easy problems. So since we have about 2 months of time, I don't think solving easy problems will improve yourself. So just try to solve these intermediate level problems, and also some problems from bit manipulation, game theory, and graph theory. So mainly in IEEE there will definitely be a problem from graph theory, and also from dynamic programming and bit manipulation. So I won't explain you the problems and algorithms. So just try to solve first the problem solving basic, and then try to solve some medium problems from each of the categories, and then try to solve some advanced problems. Problem solving advanced one, like Morgan and the string. And I think in IEEE 14.0 we came across a problem which needed an algorithm explained in Morgan and the string, and also roads and libraries. And let me, yeah, the slideshow again. So HackerRank is the best place to start practicing. And moreover, what if you are unfamiliar with algorithms? So there should be a place to start. So the best place to learn algorithm is TSCS problem set. So I think sharing the whole desktop is easier. I hope you can see the screen. So in CSCS, there's a category called CSCS problem set. The link is there in the slideshow. And in this problem set, there are various problems categorized into different algorithms. Like if you want to learn about sorting and searching, there are a few algorithms for sorting and searching, like bubble sort, quick sort, and for searching, binary search, and searching using segment trees, etc. So for each algorithm, there is a specific problem. So for obtaining the maximum subarray sum, for an example, we have this problem. And also for graph algorithms like Dijkstra's algorithms, which is shortest routes, and also Bellman-Ford algorithm, which have the shortest route, which is in the shortest routes number 2, that in CSES, for each algorithm that exists in the basic to medium to hard level, there's a question. So you can just try to solve this problem. So, and if you don't know the algorithm, so if you don't know how to solve this, for an example, let's go to geometry. So this is convex hull. So in these problems, you are given a set of points. You have to point out the largest polygon that you can draw from the using largest convex polygon that you can draw using those points. So if you don't know this convex hull algorithm, you can go to there's a site called CP algorithms. So I think, yeah, here. There's a site called cp-algorithms.com. In this website, in this search bar, you can search any algorithm you want, like convex hull. Yeah, convex hull construction. So under this convex hull tab, you can see that there's a tab called Gram scan algorithm. So whole algorithm is explained here, and also the C++ code is given in this page. And also, if you want to learn about polygons and there's something called oriented area of a triangle, which is very important in solving geometrical problems in IEEE Extreme. So for that also, there's a bit of explanation and code is also there. So when tackling problems, I think we have about 2 months time. So you can try solving. There are 300 problems in CSCS problem set. So you can solve 2 problems per day. To first try to solve these introductory problems. These problems just check your thinking ability, and then try to solve these graph problems and dynamic programming, and also the last set of the searching algorithms. There will be a definitely problem from this searching algorithms, because you should learn about binary index trees and segment trees. So try to solve 2 problems per day. So you might be able to solve all 300 within 2 months of time. So you can use this web CP algorithm site to learn about the algorithms. And then if you are good at algorithms, and if you are good at good at competitive programming, you can try out past IEEE Extreme problems at CS Academy. So this is the past IEEE practice link. So under this link, you will find almost all the problems, and you can try. And also the one more advantage of this page is you can try a specific algorithm, like let's see, binary search, and the problems where you need binary search to solve. If you need binary search to solve some problem, so those are categorized under this section. And also you can, under each problem, there are tags. So under tags you can think, for an example, just take odd cycle check, and under this problem you should learn about disjoint sets and also graphs. So without theory of disjoint sets, you can't solve this problem. And also this is very popular problem. You need to learn about ad hoc algorithms, like game of life is a very popular algorithms in IEEE 14.0 and 13.0, and also in 16.0 there was a problem from game of life, the variation of game of life. And also let's see this Fibonacci problem. And under Fibonacci problems, if you want to solve this, you should learn about matrix exponentiation. So if you go to this problem, the constraints are a little bit high, like 10 to the power of 9. So calculating nth Fibonacci of a very large number, like billionth Fibonacci number, there's an efficient way to calculate that within log n complexity. So you can learn about those things if you are familiar with competitive programming. So if you want to practice from the beginning, just use this site and HackerRank. If you are sure that you should be able to solve these problems, you can try the past problems. And also try to solve problems with more than 1200 rating at Code Forces. So Code Forces is a site where they usually hold a few competitions and contests, and you can try one of those contests from here. And I think I have to log in here. So more than contest, what is important is this problem set. So you can choose a difficulty. For an example, let's choose a difficulty from 1200 to 1800. And also under each problem, the algorithms that you need to know is mentioned. Like for this problem, you should learn about math and binary search. And for this problem, binary search and a little bit of brute force and mathematical optimization. So this is a good place to practice problems. So you can choose a difficulty. If problems with 1200 difficulty is easy for you, you can go for much higher difficulty, like 1600 to 2400, 2400 difficulty. So it depends on your choice. And so one more thing to add. Yeah, there are a few books that can provide you with an excellent overview on algorithms. So there's a book called Introduction to Algorithms. In that book, I think there's a misalignment here. So the second book is Competitive Programmer's Handbook. I'll just type it here. And there's an alignment error. So the second book is Competitive Programmer's Handbook. So if you are programming using C++, this is the one of the best. Only if you are coding using C++, because this book only has the examples written using C++. So if you are using Python, it's better if you can read Introduction to Algorithms. In Competitive Programmer's Handbook, there are advanced data structures which are only available in C++. So if you are using Python, you won't be able to solve those problems. So there are some data structures like ordered set and few more bit sets, etc., which are only available in C++ and C. So if you are using Python, there's no point reading this book. You can just only refer Introduction to Algorithms. So let's move to the next section. I'll hand over this to Rahal.
Yeah, so basically wanted to highlight a couple of points, such as like why would you want to participate in a competition like this? So especially if you haven't taken part before, you might be wondering. So well, I think the most important reason is it's interesting and entertaining. So as I think people in the engineering discipline, all of us love the chance to solve some sort of puzzle. I think we find it very entertaining. So I think that is probably one of the most important reasons, you could say. The whole experience of participating in a competition like this is it's very interesting, entertaining, and also it gives you a lot of experience. But apart from that, it also helps you develop your critical and algorithmic thinking ability. So for example, after you have practiced various algorithms, you will, like, even you yourself will notice that when you read the problem, you look at it in a different way, and you can easily see through the story and see what the real problem that needs to be addressed is, and what sort of algorithm you will have to follow to come to an optimized solution. So that is very important in various other instances as well, like when you do research work or when you work on projects undergraduate, or even when you go on to work in a job. Having algorithmic thinking is very important, especially as a programmer. And that connects to the third point, which is obviously it improves your programming ability, because in addition to algorithmic thinking, you will be more familiar with various data structures and the advantages and disadvantages of various programming languages. You'll come to realize them as you take part in competitions like this. And also one very important thing is it will enhance teamwork and collaboration skills, because when you're playing in a group of three, you will obviously have to divide the work amongst yourself. It's very difficult to come to a high rank if you play this by yourself. You need to divide the questions among yourself. You need to divide certain areas among yourself, like such as back when we were doing, and when we were preparing for IEEE Xtreme, we divided the sort of algorithms amongst ourselves. So Praditha looked into graph theory, game theory, while I studied more on dynamic programming and greedy algorithms, so that when it came to the day of the competition, like, we could get together, discuss, and then we could code according to our strengths. So I think that is a very important thing you gain from a competition like this. And in addition, of course, there is the recognition, which is actually quite important. So like top software companies in Sri Lanka will always look for people who have had experience and who have had success in algorithmic programming competition. So if you're hoping to go into the field of software engineering and trying to join one of the top high-paying software companies, definitely having success in IEEE Xtreme will be a huge benefit. And in addition, it is also advantageous when applying for postgraduate scholarships, because certain universities, certain professors will also consider having participated and having got good results in IEEE Xtreme a huge plus. It has happened in some of our senior batches, so that's why I just wanted to mention it. So we were also asked to share a bit of our personal experience in over the past competition. So we took part in this competition in our first year itself. So we didn't actually do very well in our first year. As you can see, we didn't even prepare much, and we didn't really understand most of the algorithms. So our world rank was over 1,000, and even our country rank was around 80. But after that, we decided, we should prepare and practice and try and give this a serious attempt. So in our second year, that is 13.0, we managed to become fourth overall in the country and got a world rank of 120, which we nearly missed out on the top 100. And during the second year of our second year, we had 2 second years due to various reasons. We managed to become second in the country and got a world rank of 68. So I think that was our best year in programming, and we did a lot of work to prepare that year. We went through books, we did a lot of practice problems, and I think that's reflected in the result. And unfortunately, in the year following that, in our final year, we didn't have the time to commit to this competition, so naturally our rankings dropped slightly. But hopefully, we are hoping that more teams from the junior batches will pick things up and try and get very high ranks, because we see a lot of teams from Moratuwa and of course the School of Computing in Colombo have taken over most of the top places, top slots in the IEEE Xtreme competition. So I think Peradeniya undergraduates also have the potential to be up there. So I think it's important to prepare and give this thing a very serious go. And also, in addition to IEEE Xtreme, you should also participate in all these various local coding competitions, which are sort of like preliminary practice rounds for IEEE Xtreme, such as our very own ACES coders, and then there's Mora Xtreme hosted by Moratuwa, Jaffna coders, and then depending on the year, there are various competitions hosted by Rohuna, I think, and various other engineering faculty. So on one last note, I'd like to mention a few tips and tricks that I think we have picked up over our years. So I think one very important thing, I mentioned this earlier also, is to attempt all problems. So even the hardest ones, you should always read the question and give it a try, because maybe some simple solution might give you at least a couple of points. So if you do that to all the hard questions, the small couple of points will add up and it will give you a huge edge in the final leaderboard. So it's always important to attempt problems, because I think especially in the late hours of the competition, because it's a 24-hour competition, by the time you get into, around the 15, 18 hour, everyone is tired. So most people try to give up, but I think later on, there are questions which you can sort of score partial marks easily. So it's always important to read and attempt a new question when it is uploaded. And again, there's always more than one approach to solve a problem. So there are the brute force or simple approaches which will give you partial marks. So that in a way is, it's worth trying. And then there are slightly more optimized solutions which will give you maybe 60 to 70% of the mark. And then the final optimized solution, which will give you the full perfect score. And for some problems, there's more than one way to get the full score also. So don't get bogged down thinking in one very specific way, because for some problems, the way you attempt it in a brute force manner and the optimized solution will have two completely different approaches. So always try and think outside the box and don't get stuck in one line of thought. And one very important thing is to sort of discuss, divide and conquer. So what that means is amongst your team, when a new question is released, it's important that all of you sort of get together and you read the question and you discuss it together, and then you divide it amongst yourself, and you divide the questions amongst yourself and attempt them separately. There's no point in two people coding the same question, because if one of them succeeds, the other one would have just wasted time. But it's also important to discuss the question together, because all three people will bring in useful ideas, and some questions require knowledge from graph theory and optimization and dynamic programming, which like maybe one person is an expert in one area and the other is an expert in other. So it's always very important to discuss amongst yourself, but in the end you have to like divide the work between each other and attempt the solutions by yourself. And again, time management and strategy is also something very important. What this means is basically you shouldn't get stuck on one single problem. Like sometimes you come to that point where you feel like you are almost at solution. You just have to do try and get a couple more test cases correct, and then you spend hours and hours trying to debug it and change it so that or you get 100% of the score instead of being stuck at like 75 or 80. So maybe at times like that, it might be more beneficial to just drop the question and go solve something else, because you might be able to make up a lot more marks that way. So it's always important not to get stuck on one thing and to like keep going, because time matters. You only have 24 hours to solve these problems, so you have to manage your time and strategize. And of course, when in doubt, use Google. So what this means is you cannot copy code from the internet. You're not allowed to plagiarize code, or you have to follow the code of conduct and code of ethics of the competition. But of course, if you don't know how to do something simple, something basic, you can always look it up on Google. Or if you've forgotten a part of some algorithm, you can always search on Google. So think of it as like an open book exam. So you can't directly copy the answer from Google, and obviously almost all of these questions will not have the answers directly on Google, but you can sort of on the go read on Google and try and understand algorithms which will help you address these questions, and then that will help you get a somewhat optimized solution. So I think that sort of brings us to the end of our segment of the presentation. I think we'll have the Q&A session at the very end, so I'll hand the controls over back to Damayanti.
Thank you, Mr. Rahal Nanayakkara and Mr. Praditha Alwis. So up next, let's invite Mr. Viraj Ariyawangsha, the ambassador of the IEEE Xtreme 17.0, also the secretary of IEEE student branch of University of Peradeniya, to explain further about our program, Xtreme.pera-23, leading to IEEE Xtreme 17.0. And also, if you all have any questions, please feel free to ask at the Q&A session, which will be at the end of this session.
Thank you very much, Damayanti. I hope I'm audible.
Yes, Viraj.
Okay, thank you. So yeah, it's glad to have you all here, especially Rahal and Praditha. So thank you very much for that insightful session. So let me first of all introduce myself. I'm Viraj Ariyawangsha, as Damayanti mentioned. So I'll be the ambassador for University of Peradeniya from IEEE Xtreme this year. So and we got a good understanding of what IEEE Xtreme is. So let me go over a brief description of what it is to our university and how we can take part, and what's different from IEEE general system to this year's IEEE Xtreme. So first of all, let me introduce what this program is. So this is the first of a series of programs and events conducted under the name Xtreme.pera-23, which is a series of programs that we are conducting to guide you and train you towards acing IEEE Xtreme 17.0. So there were a lot of sources and a lot of methods that as our speakers mentioned and discussed about when getting prepared for IEEE Extreme. So through this program, we hope to get you through at least some of those knowledge bases, as well as guide you and prepare you for Extreme that will happen on 28th of October 2023. So get yourself ready. So that's the date, 28th of October 2023. So we have about 7 weeks, and I guess we all can look forward to that. So yeah, so after this is the first session, and we'll be having many such sessions in the coming upcoming weeks that we can get to know about more what IEEE Extreme is and how we can take part. So okay, so about today's content. So I'll briefly go through the procedure of applying for IEEE Extreme and some important sources of knowledge that you can use to get to know more about IEEE Extreme. So first of all, I'll share my screen. So I hope you can see my screen. So this is the official website of our student branch, IEEE student branch of University of Peradeniya. It's IEEE.soc.pdn.ac.lk. So I'll put the link in the chat as well. So the link is in the chat. You can go to that page. So that is the main website of our student branch where we post all the information. And in that website, there is a page under events as Xtreme.pera. So go to that site, and there are everything related to IEEE Extreme here at our university will be posted. So you can refer to that, and there are so many links and so many information there. So first of all, the date is 28th of October 2023, and IEEEXtreme.org, that is the main website of IEEE Extreme. So you can visit that as well. That is where the main source of information is coming. And then you have the procedure to register and compete for IEEE Extreme. So so you can refer to that page. There are a few steps here, and the first thing you have to do is you have to prepare a team. So you have to come up with a team of 3 to 4 members. So of that 3 members, you can have all of them as undergraduate members, or a maximum of 2 members as graduate IEEE members. So you can refer more details from the IEEE Extreme page as well. And the main constraint in this step is that all the members of the group should have the IEEE student membership. And if you don't have it yet, you can purchase it by clicking this link here. So it goes to the IEEE membership page where you can purchase the membership. So you have to join in as a student. So and here after that you have to once you click this link, click this button, you have to create a IEEE account which is free of charge, and then you can purchase the IEEE membership where you will be charged some amount. So actually we have some plans underway to sponsor some teams to get their memberships. So we'll be notifying them in the future. So stay in touch. And then after the membership and teaming up process is done, then you have to find a proctor. So proctors are IEEE senior members, professional members, who will be acting as invigilators or actually proctors during the competition on 28th of October. So there are 4 proctors registered from our student branch. So you can access the information from this button here. So once you click this, it goes to a Google Sheet as proctor details for teams IEEE Xtreme 17.0. So this is a database where we have updated all the details about the proctors we have. So what you have to do is read these instructions carefully. And then in the second sheet, that's actually proctor details. There are the names and emails of the proctors who you can ask to act as proctors for you. So what you have to do is select one out of these 4. One proctor can proctor up to 20 teams. So if the limit is not exceeded, you can ask them through mail to you can request them to act as a proctor through mail. And if they agree, then you can add them as your proctor in the team registration process. So I'll be going over the team registration process in a while. So just what you have to do is come to this data sheet and select one of the proctors you would like. We have Dr. Rahal Nanayakkara, Dr. Sudhir Navaratna, Professor Roshan Ragil, and Professor Mahesh Disanayaka from our university as proctors this year. So they can actually hold up to 80 teams in this year's competition. So don't worry, we'll be assigning proctors if there was a need, if the limit exceeded. And we are taking care of all these things. So once you select a proctor for your team, email them with your the instructions are here with your team name, your team members, their registration numbers, and request them to act as a proctor for your team. So if they accept that request, they will let you know. And after that, go to this third sheet and put your team name and leader's email under each proctor. So use this the third sheet here to update it, and then you can move on to the registration process. So back to the IEEE website. So after finding a proctor, what you have to do is go to this database, which is linked by this, and update the details of your team to this sheet. So what you have to update is team name, leader's name, their contacts, and team leaders IEEE member number. So you get a member number once you get registered, and then the proctor's name and whether you have registered or not. So the way to register is here. You can click this link, which will direct you to a portal in IEEE website. So you have to log into your account to proceed. And once you log in, you come to this page. So there you have to add your team name and select the University of Peradeniya, which is already selected by your account details. And then country is selected. So your member number and everything is here. And then you have to select one of these proctors. So the one you have asked and approved, select the proctor that you have been approved for. They are here, and then you have to add their member number. So unless their member number is given here, so Dr. Rahal Nanayakkara and Dr. Sudhir Navaratna's proctor numbers are given here. And if you are trying to register under Professor Roshan Regal or Professor Mahesh Disanayake, you have to request them in your mail. Once they accept, they will share it with you. So put that member number in this portal after selecting, and then you have to submit it. And also you have to add other members as well. So that will be the registration process. So everything is guided here. Don't worry, I'm going over it. And of course, you can find this, you will be able to find this video as well in our pages. So you can look it up later. And once you have done the registration, come back to that sheet we were in and put that you have registered, you have successfully registered. Then you have to add your team members' names as well. So this will be the main datasheet that we are using to direct you to IEEE-Xtreme this year. So do not forget this step. Once you register, complete this sheet as well. So that'll be the end of fourth step. And then finally, what you have to do is practice, practice, and practice, just as our speakers guided you. So there are a lot of sources that you can use for that. So one of the main one is, as our speakers mentioned, the IEEEXtreme.org site. In there, you have a community called Practice Community. So I'll again put the link here. Go to that page and you can click on this Practice Community. So there you have to log into your account. So I already have. Actually, I have to. So once you log in, the CS Academy page will open up. So just as we saw in our speaker's presentation, there are a lot of sources, actually a lot of algorithms explained and lessons, and also practice challenges you can try out. So you can use that as a good opportunity to train. And also you can use HackerRank, and you can always refer to other Google sites and YouTube for your knowledge. And of course, we'll be guiding and we'll be organizing many events during these 7 weeks to guide you and help you train for IEEE-Xtreme 17.0. So that'll be the main points that I want to cover today. And just of course, go through this site. So there are a lot of information here. There's a countdown. We have 44 days, and also there are the information about the champions and what winners get, the prizes and everything. So go through this page and make sure you understand these facts, and make sure you're updated. And of course, contact us for any further clarifications. You can always contact me through my email. I'll put it as well, and of course you can see it in our website as well. So there's my email and my phone number. So, and also our IEEE student branch email. So you can always contact us through these links. Do contact us and inquire if there is any. So that's what I wanted to convey to you. And as an ending note, there's an exciting announcement. So we'll be selecting the best team from University of Peradeniya this year, and we'll be giving valuable prizes for them as well. So these prizes will be unveiled later in the program. So stay tuned and do your homeworks, and hope to see you in IEEE-Xtreme 17.0. So Damayanti, it's back over to you.
Thank you, Viraj. So is there any questions to ask? Y'all can drop it in the chat if y'all have any questions to ask.
Please put your questions in the chat if you have any, so we can direct them to Rahal and Praditha.
So there's a question. What about using Java in the competition?
Rahal or Praditha, I think you can take it.
Yeah, I think Praditha, I think we can both comment on this. So I used Java a lot during my early years because actually that main reason was because that was the language I was most familiar with. So there are advantages because it's object oriented. You can sort of for graph theory problems or for certain problems you can just uh, define objects, create objects, and use that to solve problems. But I think sometimes it can be a bit wordy or a bit lengthy because in Java you have to write a lot of statements to get something done. I think you can write it much shorter in a language like Python, I guess. Uh, what do you think, Praditha?
Yeah. So in Java, I think to implement something like ordered set, so even to implement that Discret's algorithm, you need a little bit lengthy code.
Yeah.
So in Python, you can just do it within. The best example is, I think, IEEE-Xtreme 14.0, we came across an algorithm called bipartite matching. So for that problem, I think Rahal tried to implement it using about 100 lines of codes, but our other team member, Satira, implemented it within 30 to 35 code lines using Python.
Yeah.
So one more thing, my opinion is if you are familiar with Java, I think it's better to continue for this IEEE-Xtreme competition. So because you don't have much time to learn a new language like Python or C++, there isn't much time. You only have about 2 months of time. So if you're familiar with Java, you can continue using Java because most of the C++ codes can be converted easily to Java also. So
Yeah, exactly. I think at this point for this year's competition, it is more important to learn algorithms and practice rather than learning a new language.
Also, there's a question. How long did it take for you to practice for 14.0? IEEE-Xtreme 14.0.
I think um, we practice. It wasn't. It was over quite a long period of time, but I think we like throughout the whole year we were continuously doing problems on hacker rank and going through algorithm books and
I think we solved more than 200 problems in HackerRank also.
yeah, continue. And I think back then there was everyone was trying to be at the top of the leaderboard on HackerRank also. There's a leaderboard for algorithm problems, practice problems in HackerRank. So like we were solving problems, trying to get on top of that also, and in the process we were learning a lot of algorithms. So I think it's not something you do like a short period of time. So the first time you play IEEE Xtreme, it's unlikely that you'll get a very high rank. But then after that, you practice, you do a little bit of work throughout the year, practice and read some algorithms in your free time, and then by the next year you can like go for a really good place. So I mean, it's a continuous process. I think not something you do immediately.
There's another question. Is there a rule book or guidelines?
If you refer to the IEEEXtreme.org site, there are the rules and regulations of the competition. I think Viraj will also be able to share his thoughts on this.
Let me share my screen. So if you can see my screen, this is the IEEEXtreme.org main page, and there is a link as rules here. So here you can see all the guidelines and everything. So I'll put the link to the chat as well. So there are all the rules and regulations. You can refer to them about many aspects. Yeah, so this is the main source of information you'd have.
Also, there's a question, when the execution time exceeds somehow, how can we learn to get rid of this problem and how to practice to get an optimized code?
Yeah, so usually if the execution time, if you get a time limit exception, that means the algorithm you're trying to implement will not most likely work. So I mean, for example, if you're trying to find some sort of certain pair of elements in a 2 by 2 array, and you're doing a pairwise, you're searching all possible pairs, and then you'll most likely get a time limit exceeding error. So what this means is you'll have to change your approach in how you address the problem. So instead of searching all 2 by 2 pairs, you can like pre-compute something and then like look at the possibilities. So basically what you want to do is you have to try and reduce the the complexity of the algorithm. So if your algorithm runs in big O of n squared, you might want to try and think of something that runs in big O of n log n or big O of n. Isn't that so, Praditha? I think.
Yeah. And another approach is, if you are not familiar with big O notation, just count the number of iterations. If you are using a loop or something, just usually the maximum number of iterations you can do within 10 seconds. I think for Python, the time limit is 10 seconds, and for C++, it's I think 1 second. So the number of iterations total number of iterations that you can done within that time constraint is about 10 to the power 7. That means about 10 million. So if you are using 2 nested loops, which have 10 to the power 6 iterations, so then the total number of iterations will be 10 to the power 12. So that will definitely get timeout. The time limit will definitely get exceeded. So if you are not familiar with big O notation, just try to reduce the number of iterations. For an examples, if you are in the nested loop, so I can explain that using the whiteboard also. So I'll share. So just what I'm trying to say is, just suppose I'll code in Python. You are using two loops, which have 10 to the power 6. So again 4. So this loop will definitely time out because you cannot do 10 to the power 12 calculations within 10 seconds. For Python, the time limit is 10 seconds. So what you can do here is just just think what you are doing in this second loop, in this nested loop, and try to reduce the complexity to about, you can try to the reduce number of iterations using a login approach. So usually this, I think explaining what the big notation is, we don't have much time. So what you can do is try to do something like binary search, or try to use an algorithm which has log n complexity. You can try to just consider like you can divide the problem into subparts and try to solve it under that loop. Like you will definitely have to reduce this loop to about, let's say, log 10 to the power 6. So log means base 2. So this will be about 26. So if you are doing 26 into the 10 to the power 6 here, change it to 10 to the power 6. So if you are doing something here, the total number of iterations will be 26 into 10 to the power 6. So here it won't exceed that 10 to the power 7 constraint. So always, if you are not familiar with big O notation, try to minimize the number of iterations. Try to reduce. So if you are doing about 10 to the power 12 iterations, it's like you are doing something n to the power of n, like n squared number of iterations. So if you are using n log n number of iterations,